Hello guys, you're welcome once again to MathsKeypoints. We shall be looking at joint variation. Don't forget, this is the channel for the solution to O-level mathematics exam questions, especially for WAEC, NECO and JAMB. Let's dive straight in. Now let's take joint variation. Now I want to give you 3 points that will enable you understand whenever you see a question in joint variation, so that you will know what to do. The first point is this: if the question involves 3 or more variables, note that that question is under joint variation. The second point, if the statement has wordings like varies directly and inversely, also note that that question is under joint variation. I mean, if there's a combination of both directly and inversely. The third point, if you see statements like one of the variables, let's say A, varies jointly, I'm writing the jointly in capital letters. Jointly, it simply means the question is under joint variation. Now, let's take an example. Now, if the volume V of a cylinder varies directly with the square of its radius, r square, and height h, we can express this as, they said the volume V varies directly as the square of its radius, and also the height. Now, in case you missed the video on direct and inverse variations, I would like you to go back and watch them. Now, this implies that V is equal to K R square H. Remember that you always solve for the K before you proceed. This our K is the constant of proportionality. Also note that we have V here as one of the variables, R as the second variable, and H as the third variable, which satisfies our first statement here that if the question involves 3 or more variables, note that that question is under joint variation. Now let's proceed to solve examples so that you get a big picture. Now let's take the first example. We have been told that given that F varies jointly as t squared and r, F is equal to 144 when t is equal to 4 and r is equal to 6. Find t when F is equal to 3 to 4 and r is equal to 24. From this example 1, you will see the statement varies jointly. It simply tells you that the equation is under joint variation. So let's proceed and do justice to it. Solution: F varies jointly as t squared and r. From here, our F is equal to kt squared r. Now remember, you always solve for k first. Now I want k to stand alone. What do? We divide both sides by t squared r. We will now have that k is equal to F over t squared r. Now you have been given the values. F is 144 and t is 4 squared and r is 6. From here we have 144 over 16 times 6. From here, if you solve, our k is equal to 3 over 2. That is the k, the value of the k. If you divide what we have here, you have that k is equal to 3 over 2. But we know that F is equal to kt squared r. Don't forget, from this equation, our F is equal to kt squared r, and we have known the value of k. So anywhere you see k, you put 3 over 2. But I said we should find find t when F is equal to 324 and R is equal to 24. So from here, We are looking for t. So from here, what do? We divide both sides by kr, which implies that our t square is equal to what? F over what? Kr. Taking the square root of both sides, we have that t is equal to what? Square root of f over what? Kr. Now we have been given the values, so t is equal to what? Square root. What is f? 324. And k is what? 3 over 2 times what? What is r? 24. Now, if you divide both sides, you have 2 here, 1, 2 here, what? 12. You have 324 over what? 3 times 12. From here, we have our t as equal to what? 324 divided by what? 36. This is equal to what? Square root of what? 36 here 1, 36 here 9. We have square root of 9. Therefore, our t is equal to what? 3. So this is the answer. So let's take the last example here. Example 2 says, if a varies directly as t and inversely as w, and a is equal to 10 when t is equal to 8, and w is equal to 5. Find the law connecting at and w, and find a when t is equal to 6 and w is equal to 2.5. As you can see, to confirm that this question is under joint variation, we have statement as varies directly and inversely. We also have the variables a, t, and what? W, which is what? 3. So on this channel, we give you the key points so you can solve any question in mathematics. So let's do justice to this. It says if a varies directly as t and the same a varies inversely as a w, okay? Now this 1 over w means inversely, okay? Now this simply means that this a varies directly as t and inversely as what? W. This simply means that this a varies directly as t and inversely as w. This simply means that this a varies directly as t and inversely as what? W, because t times 1 is t. Now this implies that a is equal to what? K t over what? W. Now take note of this equation. Let's call it equation 1. Now the statement says that a is equal to 10 when t is equal to 8 and w is equal to 5. We should find the law connecting a, t, and w. Now don't forget, you must look for the k first. So from equation 1, k is equal to aw over what? T. Okay? Now, when you insert the figures, you have that k is equal to what is a? A is 10, w is what? 5, and t is what? 8. K is equal to 50 over what? 8. 2 here, 4. 2 here, 25. So k is equal to 25 over what? 4. This implies that k is equal to 25 over 4. Now, from equation 1, we have that a is equal to k t over w. So k is what? 25 over 4 times t over what? W, which is 25t over 4w. Now this simply means a is equal to 25t over 4w. This equation you're seeing here is the law connecting a, t, and what? W. The only difference is that we inserted the value of what? K, which is 25 over 4, into this equation 1. Now, in this equation connecting them, we have A here, we have T here, and we have what? W. Now, let us proceed. The second one says, find A when T is equal to 6 and W is equal to what? 2.5. Now, from the same equation 1 again, or okay, let's say from this equation, this law connecting AT and W, we have that from A equal to 25T over 4W, we have that A is equal to 25. They say T is what? 6. W is what? 2.5. This is equal to 25 times 6 divided by 4 times 25 over what? 10. Now, this implies that A is equal to what? Let's come back to this place. We have that 25 times 6 times 10 divided by 4 times 25. 25 here, 1. 25 here, 1. 2 here, 2. 2 here, what? 3. 2 here, 1. 2 here, what? 5. We have that A is equal to what? 3 times 5, which is what? 15. Now, this implies that our A, that's what we should find A, our A is equal to what? 15. So this is the answer. As easy as what? ABCD. Please subscribe to this channel, like and share with your friends, and also hit that notification bell so whenever we upload new videos, you will be notified. Thank you.